So, welcome. This video is going to talk about slope and slope-intercept form of a line. Now, for some reason, people get really hung up on this, and I'm not sure why. But I am going to try to explain it in a slightly different way because, well, we see this daily, we just don't recognize it. Couple of things. So back when I was young, I was driving through West Virginia, and I'm from Michigan, so yeah, I'm not really used to mountains. We don't have any really. So I'm driving through the mountains, and a semi is coming up behind me. Well, I look down at my speedometer. I'm doing 80. The semi passes me on a downhill. I'm like, what in the world is going on? And then off to the side, on the uphill, I see these ramps. And I'm like, what in the hell is that? And I didn't realize until later, when somebody told me, it wasn't a realization, somebody just flat out told me, these are get out of jail free cards for the semis, because they might be carrying a load so heavy that the slope of the road is more than their brakes can take, and they can't slow down. So this is, I don't remember exactly what they call them, but it allows the truck a chance to slow down, and it typically has like sand barriers, so it'll stop the truck. So it was just a weird thing for me. But I mean, truckers see it a lot. The slope of the road actually depends on what they can do and what they can't do. And later on in this, right, on I-77 there through West Virginia, I saw another truck that was doing like 30, 40 miles an hour going downhill and constantly trying to downshift. And I didn't realize it then until it's like, oh, well, shit, yeah, he's trying to not have a runaway truck. So, I don't know. It was just kind of interesting. So you never know when this is going to happen. Now, the slope, the grade is what they call it, but the slope of the road is given in a slightly different format than what we're going to find it here. We're going to find it more as a rate of change. So we're going to have a top number and a bottom number. It's going to be in ratio. The other piece, or the other way to do it, is to do it in percentages. And that's typically the way road grade is done. Is they're trying to keep it to a 5% drop or less. 5% means for every 100 feet you drive in a straight horizontal line, you would drop 5 feet on the road. Or raise 5 feet if you're going the other way. So that's the concept of slope. How do we find it? Well, to start off, we have to define it. What do we mean by slope? And math people around the world have basically come together and said, let's all do it the same way, and let's do it this way. Why? Because it's the same and it's this way. Sometimes there's no why behind it. All right, so the idea here is that you have a couple of points. Which points? Any points. It doesn't really matter. So let's take a couple of points. Let's take, this is going to be -4, 5. The other -4, the kind with the 4 with the negative. And let's take something like -1, 8. Now, here it uses these subscripts. And what's happening is it's trying to get you to see that it's using the x and y coordinates. But the subscripts tell you that they're two different points. So we can call this point 1 and this point 2. So wherever we see a y1 and an x1, we're going to put those points in for those variables. Over here we have x2 comma y2. So wherever we see an x2 or a y2, we'll put in those values. All we have to do is substitute that in. So let's do that. We've got y2, so that's an 8. Now, minus. The minus has to be, we're talking about the change. And so the change is the difference between them. y1 is 5. Notice I'm putting a parenthesis around it. It's going to have an effect here in x's. x2 is -1 minus, and then x1 is -4. So So if we were to clean this up, we get 3 on top. We get -1 minus -4 is going to give us a 3 on the bottom, and we get a slope of 1. So 3 over 3 is 1. Now, this means something. If we were to write it as a fraction, well, that's not contrasted enough there. Let's try blue. If we were to write 1 as a fraction, then what we would see is that for every 1 we go up, we go positive on the x or right another 1. So in effect, we're doing this stair-step thing. We're going up 1, over 1, up 1, over 1. And eventually, we get to the other point. That's the idea. So you look at the 2 points, and you're basically describing what you're doing between the 2 points. Now, this is an average. So later on, if you want to know, like, what is he doing right now? What about right now? What about right now? Then that's calculus. But anyway, no big deal. All right, second big question I get. Well, Phil, I screwed up. How did you screw up? Well, I called -4 and 5 0.2. Oh, okay. No big deal. And why is that? Well, let's take a look at that slope equation. M is equal to y2 minus y1 over x2 minus x1. If I were to pull out a -1 from each of these, I'm going to factor out a -1, that reverses the subtraction. Whoops, this is x1 minus x2, and then we pulled out that -1. So I'm allowed to do that. It doesn't change the value of it because I just factored. I'm just staying right where I was. So this equal sign allows me to say that, hey, whatever I'm doing here, I'm not changing the value. I'm just rewriting it structurally. Now, that part, however, cancels out those -1s, because -1 divided by -1, that's just 1. 1 times anything, well, that's just the anything. So look at the order. Do you see how they both changed? What this implies is these 2 points are arbitrary. You can go ahead and pick whatever point you want to be point 2 and whatever point you want to be point 1. Just make sure that when you decide that you're using them in the same order within the equation. That's really it. So if we want to do that really quick, I don't have a lot of room left, so I'm just going to go ahead and utilize this area over the graph. I'm going to reverse the roles to show you that it does in fact work, at least numerically. Come on. You can do it. There you go. Good job. All right, so now let's say I use point 1 and point 2 like this. So I reverse the roles. All right, well then y2 is 5 minus y1 is 8. And you're like, whoa, we got a different answer. Wait, it's not the answer on top that can't be different. It's the m value. So then we look at point 2x, and we have -4, and we subtract off -1. That's going to give us -3 over -3, which is still just 1. You still get the same answer. And that's okay. So, which one is 1? Which one is 2? Whichever one you want. It's okay. Pick one. It doesn't matter. The next little piece, and we're not really going to get into it here, we're just going to look at the structure of it. The next little piece is we can take this value here, and we can put it into an equation format called the slope-intercept form. It's called that because it gives you 2 values. If you have an equation in this format, then the m stands for your slope. It's your rate of change. The b stands for your y value of the y-intercept. Some people would just simply say, when they go back to report it, they're like, oh, what's the y-intercept of this? Oh, well, it's 3. No, it's technically not 3. The y-intercept is a point. The b value happens to be the y value of that point. So you have a slope of m, and the b value is the y coordinate. The y-intercept in this case is 0 comma b, whatever the value of b is. This plus sign says essentially, look at whatever the sign of b is and take that with it. So you don't have to worry so much about it. All right, just a basic introduction into slopes and lines as far as the slope-intercept form. If you have any questions, stay tuned. We're going to go into a few examples.